So a yes. Let's allow the system to settle, and then we will be live on YouTube doing our thing today. Okay. Okay, so that's a confirmation that we are on YouTube now. So you just give me a minute or two to set up other protocols. Just give me a minute or two to set up the protocol. Okay, like I said earlier, if you can hear me very well, please a yes or a no would help. Hello, okay, fine. Chisom, Ugochi. All right, that's nice. So we're going to start right away. Sorry, 1 minute. It's like I can't talk to you. I'm having a live class. I'll talk to you after now. All right, so sorry about that. Okay, so let's start. Okay, so good evening. You're on to Mamu with Jarvis, and this is our grade 11 experience. But technically today, it will not just be a grade 11 class. It's going to be more like a class covering grade 10, grade 11, and grade what? 12. And the approach for today would be more of me trying to solve questions. And in the course of solving questions, I'll be drawing our attention to certain ideas we need to remember. So the topic we're considering today is logarithm without tables. So there are two aspects to logarithm. There are logarithms that involve the use of four-figure table, and there is the aspect of logarithm that involves us not using four-figure tables. So we'll go straight away to business. Like I said, today is going to be solving all the way. We are live. In fact, one thing very interesting is that we also have students from Archdeacon Brown Education Center in Vigwe watching this video right now. So it's live. It's a live telecast, if you choose to call it that. And we're also having students from other schools coming to watch what we're doing here. So we want to plead that we try as much as possible to have a biro, have a notebook close to us, and we'll try to solve. Towards the end of the class, I'll open the platform where we can get comments. But right now, we're going to hit the road. So, like I said, it's going to be question per question. Now, the first question paper I have here is from November WAEC. That's what you may call your GC, 2006. November WAEC question paper, 2006. It's an OBJ question paper. And I'm going to be solving question number 1 there. I will write the question on the board. So I'll just write here, November 2006. Question number 1, OBJ. It's an OBJ question, and it says, please, can I get a confirmation that you're hearing me well? A chat will do yes or no. So I'm sure that you can hear me as I speak. All right. I'm also watching the YouTube proceedings on YouTube to see if they are beautiful. Thank you very much, Ugochi. Thank you, Chisom. I'm also watching the feedback from the YouTube to be sure that all of us are carried along. All right. Now, this is the first question I'll be solving. November 2006, question number 1. It says simplify what? Log 27 over log 9. Log 27 over log 9. Now, logarithm is not different from your indices. In fact, there are 4 words that are used interchangeably when we talk about logarithm. There's a matter of index, there's a matter of superscript, there's a matter of logarithm, and there's also the matter of exponent. So these 4 words can be used interchangeably. That's why when we define logarithm, we say logarithm is the what? The power to which, the logarithm of a number is a power to which a base is raised. So that number to which that base is raised is called the log. Now, with that said, it strives on the concept of what? Prime numbers. I look at 27. What's the prime number there? It's 3. So this will be log what? 3. How many times should I multiply 3 to get 27? It will be 3 times. Divided by what? Log 3. How many times will I multiply 3 to get 9? That will be 2 times. Then we're going to rewrite this to be this. Remember that if I have log a raised to the power of n, I can write this as what? N log a. This is a log you need to remember. This is another way I can write this value. I can write this to be this. So if that is understood, this will now be what? 2 log 3. This is similar to this. So what will happen is that this will cancel this. And what happens? Your final answer becomes what? 3 over 2. So if you have taken that exam, that is what that answer will be for question number 1. Now, the next question we have is question number 34. Question number 34. In question number 34, we are told that log 32 base 8 is equal to what? X plus 2. Log 32 to base 8 is equal to x plus 2. So how do we solve this? How do we have this? Very simple too. Remember that if you have log a to base x equal to n, this will be what? X to the power of n equal to a. So we can say that this is the logarithm form and this is the index form. So we can write the logarithm form as the index form. Now this is the idea you need to solve this one. So if we borrow a leaf from this concept, we're going to have that this will be what? 8 raised to the power of x plus 2 being equal to what? 32. The next thing we look at is this. Remember that anytime you're handling logarithm, your knowledge of indices must be close by. The knowledge of what? Indices must be what? Close by. So what? X raised to the power of x plus 2 is equal to what? 32. Now, what is the prime number of 8? What's the prime number of what? 32. So let's come down here to write this. This will be what? 2 raised to the power of 3, because if I multiply 2 3 times, I'm going to get what? 8 into x plus 2, and this will be equal to what? 2 raised to the power of what? How many times will I multiply 2 to get 35? So I will test. 2 times 2, 4, times another 2, 8, times another 2, 16, times another 2, what? 32. So I would have multiplied 2 how many times? 5 times. So with this done, this will now be equal to what? 3 into x plus 2 equal to what? What? 5. So this will now be 3x plus 6 equal to what? 5. So from this point, your normal knowledge of what arithmetic will come, or rather of algebra comes to play. This becomes 3x equal to what? 5. This is a king. If it crosses over, it becomes what? A slave. And a slave is what? A negative minus what? 6. Remember that the fundamental idea of algebra is to keep the unknown on the left-hand side and the known on the right-hand side. So the question is, what is a known? Anything that is a number is known because that's a definite value. Anything that is not having a definite value, whose value can change, like the weather or wind, is the unknown. So by this understanding, unknown equal to known. 3x will now be equal to what? -1. I have 5 naira, I have to pay 6 naira. So I'll pay 5 naira and I'll still have 1 naira left. And as such, at this point, I'll divide both sides by 3, and I have that x will be equal to what? -1/3. So what you observe from this is that in every WAEC exam, OBJ questions, you always have 2 questions on logarithm. 2 questions. So always project in your mind that you're going to face 2 questions on the logarithm. I'll give us a minute or 2 to settle things out, and then we'll go to the next question. Okay, just another confirmation. I'm getting a feedback that we're not seeing the board very clearly. Is that true? Please confirm. Is this better? Because I just got a feedback that they're not seeing the board very well. So I've had to do a little adjustment. So let's confirm. All right. Okay, so for my what would that be now? For my YouTube audience, please confirm that you can see the board very well. Drop that as a chat. All right. Okay, so we're done with that question. So let's go to the next. All right, so I'll clean off and then we'll try to solve the next. It's recorded, so you can always go back to the channel to download or rewatch. Okay, the next question we're going to consider will be that of, let's see what year that is. November 2002, and it's a theory question. November 2002. November 2002. Question number 2A. November 2002. Question number 2A, and it's theory. November 2002. Question number 2A. Right, so the question says that you should simplify. What's that? Log 10 base 10 minus 2 log 1/5 base 10 minus log 2.5 base 10. All of them are in base 10. Log 10 to base 10 minus 2 log 1/5 base 10 minus log 2.5 base 10. 2.5 base 10. So how do you go about solving this? How do we go about solving this? Now, look at this. We have a law from logarithm that says that log x minus log y is the same thing as log what? X over y, which means minus will suggest what? Division. When you subtract logs, what essentially you are doing to the numbers, when you subtract logs, you're essentially dividing the numbers. When you subtract logs, you're essentially dividing the numbers. So if this idea is understood, it will mean that this will now be equal to log 10. Okay, there's something else, there's something we ought to do first. We need to take care of this. If not, we're going to have a little problem. So I'll come to this side of my board to handle this part. Now, what is 2 log 1 over 5 base 10? How do we simplify this? I hope you know that we have said that n log a is the same thing as log what? A raised to the power of n. So we need to take care of this, and this will give us what? Log what? 1 over 5 all raised to the power of 2 to base 10. Log 1 over 5 raised to the power of n to base 10. So this is what we need, this is what we're going to have here. Now, you can simplify this. This will be what? Log 1 over 25. Because 1 squared is 1, 5 squared is what? 25 in base 10. Once you've cleared this, you bring this back to this equation, and you're going to have log 10 base 10 minus log 1 over 25 base 10 minus log what? 2.5 base 10. Now, minus suggests division. Minus here suggests what? Division. It implies that these two things here will suggest that they are denominators. So if I'm going to write in one log description, it's going to be log 10 divided by what? 1 over 25 times 2.5. Now, this is where a lot of students might have a little issue. Yeah, but how is it? Now, let's go back a little, because this is where I'm suspecting a lot of students might begin to ask, this is this divided by this, divided by what? 2.5. So what is the implication of this? This will mean what? Log to base 10 divided by 1 over 5 times 2.5. So what do? You can actually cancel out. Remember that a denominator of a denominator is a numerator, because this is this divided by 1 over 25. It means that the figure you're going to get will be a very big figure. All right, so let's continue from here. I'm taking pains to explain it, because this is where I'm suspecting students might have a little bit of an issue. All right, so this will now be what? Log 10 over, so I can write this together, 2.5 over 25. I'm taking pains to do this so that for students who may have issues see what's happening, for them to have a clarity of this. And this will also be equal to log 10 over, I multiply this by 10, I multiply this by 10. What I do to this, I must do to this. This will now give me what? 25 over what? 250. So this will give me what? 10 log what? 10 over. What was going to happen here? This 25 will cancel this 25, and I'll be left with 10. So this will be 1 over 10. If 1 is divided by 1 over 10, it will mean that what I'm actually going to have will be more like what? 10 times 10. And somebody is asking a question, how is it 10 times 10? 10 divided by 1 over 10 will mean what? 10 times 10. So that's how I'm getting 10 times 10. Now, what does this mean? This will be what? Log 10 raised to the power of 2. How many 10s can you see? 2. What is the act is multiplication. So this will be what? 10 to the power of 2 to base 10. And this will simply give me what? 2 log 10 base 10. And this will simply be what? 2. Now the next question a student might ask, how is 2 log 10 to base 10? Now 2. Because we have a rule that says that if I take the logarithm of a number to the same base, look at this, log A to base A must be equal to 1. What it means is that 10 raised to the power of 1 must be equal to 10. 10 raised to the power of 1 means that 10 is just there, or it's multiplied once, if that were possible. So this is 10 raised to the power of 1, that will be 10. So that's how my answer becomes what? 2. Let's go over the process once again. We started by writing the question. We had to draw from this understanding log x minus log y equal to log x over y. And I told us that negative will suggest what? Division. If I subtract logs, I'm dividing them. So this will divide this and then divide this. But what does that mean? It means that this number is actually a denominator. And I can write this to be 2.5 divided by 25. I can increase this. If I increase the numerator, I must increase what? The denominator. Remember that in this kingdom, this is the numerator and this is the denominator. If I look at everything here will be denominator. But when I consider just this kingdom, this underwater kingdom, this is numerator and this is denominator. So with that, I'm going to have what? 1 over 10. Now, 10 divided by 1 over 10. There's a technique we use in class to handle this. This is numerator. This is a denominator. This is a numerator. It's like a mirror. It's turned upside down. So this is a numerator. So numerator will always go with numerator. And that's why at the end I'm having what? 10 times 10. And 10 times 10 will mean, from our knowledge of indices, 10 raised to the power of what? 2. And if you got that right, you apply this idea here. And log A to base A is, okay, not that one yet. We'll apply, what is the idea? Where did you write that? Have I cleaned that? Log 10 raised to the power of 2 to base 10 would mean that, I think I said that if you have log A raised to the power of n to a particular base, it will, or to this base, for instance, log A raised to the power of n will mean what? N log A. So that's the first thing I applied, and this two will come out here. Because the power of a number means that that number is multiplying the log. And then at the end of the day, we have log 10 to base 10. Because the bases are the same, what we're going to have finally is what? 2. That's how that problem is cleared out. And this, I only had to overly explain this because I'm assuming that some of us, when we see questions like this, we want to do what? Run away. So that settles that for question 2A, theory of November 2002, and then we'll proceed to solve another one. All right. Okay, so we're going to solve another one. Still in that same manner, we're going to solve another one. We're going to solve another. All right, now let's look at this. Let's look at this. Okay, so we can clean off. Okay, let's give ourselves a minute or two to breathe. Let's give ourselves a moment or two to breathe. I want to give us a little advice as we walk. Try as much as possible to write as we solve, so that by the time you're rewatching, you have a clearer understanding of what has been done. All right, so give us a minute or two to calm down so we can continue. Okay. I will just take off this part alone. When I'm ready to solve, I'll add the other one. Now, this one is coming from November 2011. This is November 2011, and it is question 1B. Question 1B, and it's a theory question. Question 1B, and it's a theory question. Where that the logarithm of this number, or these numbers given to us, are all in base 10. The logarithm of this number given to us are all in base 10. So let's find the problem. It says, without using tables or calculator, simplify 1/3 log 125/8 minus 2 log 2/5 plus log 80/125. Remember that we have been told that they are all in base 10. So let's do that quickly and then we'll start. All right, so let's go. Okay, now remember that logarithm comes under a branch of mathematics called arithmetic. So logarithm is essentially what? Arithmetic. Please, when you see problems like this, don't be in a hurry to solve. The first thing you need to do, please, let's watch, is to take care of this, and simplify this. I'll come again, take care of this, and do what? Simplify this. To simplify this will mean that you will reduce to the lowest 10. So let's pick them one after the other. This will be equal to log 125/8, all raised to the power of 1/3. I hope nobody's in doubt on this. If I have A log B, this would imply log B raised to the power of A. So that's what I've done. This is essentially a power with respect to this number. Minus, I take care of this also, this will be log 2/5, all raised to the power of what? 2. Notice that here I said to the power of 2 because the number here is 2. Here the number here is 1/3, so it will be raised to the power of 1/3. Plus, I'm going to simplify this. So somewhere in my book, I'm going to say 80 divided by 125. What can divide 80 and 125? Can anything divide that? 5 can. 5 here will give me what? 16. 5 here will give me what? 25. So that will be 16 over what? 25. So that will be log 16/25. The next thing I'll do is to simplify this. Now look at this carefully. How many times will I multiply 2 to get 8? Can I get a chat response for that? How many times will I multiply? Because take note, anytime you see an even number, especially when you're dealing with logarithm and indices, it is safe to imagine that number, that the base number we're looking for there is what? 2. So I know this will be 2. This number is ending with 5. So I know that the prime factor I'm looking for there is going to be what? 5. So the next thing I try to do is to determine how many times am I going to multiply 5 to get 125. And if you do that correctly, please, if you are with me, you can send a chat. That will be 3. If I do this correctly, that will be what? 2. That will be 3. All raised to the power of what? 1/3. Minus. I can open this one up. This will be what? Log 2 raised to this square will affect this and will affect this. So this will be what? 4 over 25 plus what? Log what? 16 over 25. And remember, we said that if this will affect this, it will also affect this. So maybe I need to take one more line to help us with that. And that will be 5 raised to the power of 3 times 1 over 3 all over 2 raised to the power of 3 times 1 over 3 minus log 4 over 25 plus log 16 over 25. Are we seeing that? So this will give you what? Log 5 over 2. How are we getting that? Are you seeing that? Are we seeing that? Minus log 4 over 25. Sorry about that. Plus log 16 over 25. So at this point, what am I expected to do at this point? What am I expected to do at this point? Now, notice that this is negative. It means what? Divide. This is what? Positive. It means what? Multiply. So I'm going to apply the implication here now. This will now be log what? 5 over 2 divided by 4 over 25 times 16 over what? 25. I put it in brackets. Divide these two and then multiply with this. So I'm going to rewrite this. Notice that when we introduce division, it only affects this one. Division always affects just the second term. So this will be 5 over 2 times 25 over 4 times 16 over 25. So with this will effectively cancel this. This will cancel this. I'm going to have 4 left here. This 4 will go and I'll have 2 and this will become 1. So I'm going to have that this will be log what? 5 times 2. And what is 5 times 2? And what is 5 times 2? This will be log 10. This negative here means divide. When we subtract logs, we are dividing the number. When we add logs, we are multiplying the number. So there is a number and there is the log. If I say log this minus log this, it means divide their numbers. And because this is plus, it will mean what? Multiply this. So this is relating these two numbers divided. Relating with this, multiply. Okay, so that is understood. This will now be log 10 to base 10. Remember we have said that the log of a number to the same base is 1. So invariably, this answer becomes what? 1. That solves that question. So you see that they are very, very easy questions. Very, very easy questions. Okay, so we're done with that. We're done with that. And then we can, okay, we're done with that. And then we can go to the next one. Is that a hand up for question? Please send a chat. If your hand up is for a question, please send a chat. Chat the question to me so that once I see the question, I'll then know what to do. So just send it as a chat. Send the question as a chat and I will deal with it that way. Right? So that takes care of that question. And we will just take a minute or two to catch our breaths and then we'll go to another question. Right. A quick reminder here that this class is recorded, so you can always rewatch it. You can always rewatch the class. You can always rewatch the class. So if there are areas, maybe because maybe some of the things are too fast for you to see, you can rewatch the class. It's recorded. That's the beautiful thing about technology. Anything taken live to YouTube is always recorded. Right. So we will clean this and then we'll go to another question. All right, so the next question comes from, this is from NECO 2002. NECO 2002. I guess some persons will be asking, where is he getting this question papers from? I have those old NECO and GC question papers when exams were exams. So those are the questions I want you to solve. If you can conquer those ones, these ones we're having today, I will walk over and try to speak for you. Right. So we are dealing with NECO now. So this is NECO. Let me be emphatic. NECO 2002 OBJ question 40. We actually have two questions here, which appears to be the pattern of NECO and some of these exam bodies. Two questions from logarithm. So if you're able to get two questions, that means you're already sure that you have 2 over 50 or 60. So, and that's an encouragement for you. All right. It says this one is quite long. It says evaluate log 6 minus log 3 all over log 8 minus log 4 divided by log 5 over log 0.2. So we have to divide this over this divided by this over this. Okay. So let's see how we handle. Let's see how we handle that question. Let's see how we handle that question. Let's see how we handle that question. Okay, so now this is divided by. It depends on your understanding of the question. Your understanding of the question and what you are seeing will determine your approach. This is one of those questions where what you're saying will determine what you're going to do. So I could start by taking care of this. I want to start by taking care of this. At the same time, I apply my laws of logarithm. Remember that log A minus log B will mean what? Log A over B. Also remember that anytime you're handling logarithm and the base is not given, assume the base to be base 10. Anytime you're handling logarithm and the base is not given to you, assume the base to be base 10. All right. So I'll be applying two ideas together. This is one of the place of interest for me. And this one's also another place of interest for me. So I'm going to write this to be what? Log 6 over 3. Remember, if we subtract logarithm, we're essentially dividing the numbers over, I'll take care of this one, log 8 over 4. The division sign here means that if I introduce a multiplication sign, it will toggle this. So this becomes log 0.2 over log 5. So what next thing I'm going to do? This will give me what? Log 2 6 divided by 3 is 2, all over log 8 divided by 4 is what? 2 times. Remember that 0.2, you can write it as a fraction. 0.2 is equal to what? 1 over 5. Are we together? 0.2 is 1 over 5. How? This is what? 2 over 10. 1 decimal place, that's 2 over 10. And when you reduce to the lowest, it becomes what? 1 over 5. Right? So this will now be what? Log 1 over 5 all over log 5. Now, at this point, this will cancel this. So I'm done with this part. My challenge now will be this one. Recall that 1 over 5 can be written as in its reciprocal form. 1 over 5 means the reciprocal of 5. So this I have written here is what? Reciprocal of 5. So 1 over 5 means what? The reciprocal of what? 5. 1 over 5 will mean what? The reciprocal of 5. So I'm now going to, where I'm going to have this now, I'm now going to write this. So this will be equal to what? Log 5 raised to the power minus 1 over log 5. So remember, again, we said something earlier, that the log of a number to any base, the log of a number to the power is same as for n log a, is that not? So if you still remember this one will now be what? Negative 1 log 5 or negative log, because 1 multiply anything will simply be that thing. Negative log over log 5. This will now be written as what? Negative. Notice I did not say negative 1. Cosmetic work. I don't need to write negative 1. It doesn't. If there's a negative 2, I'll put negative 2. Or hence is 1. I just put a negative. This. My final answer becomes what? Negative 1. So negative 1 becomes my final answer to that question. As a follow-up to that, there's also another question there. Question 41 rather. And it says 1 over 3 log p to base 10 is equal to 1. How do we solve this? So this is the next question we're going to solve. Let's just give ourselves about 30 seconds to cool down and then we'll go to this. Okay, noted. I've been told that I'm too fast. Oh, I'm very sorry. I'm very sorry. Sometimes I run very fast because I know I am recording. So you have the privilege to rewatch the video. But having said that, I will calm down. That's the post I just got. Calm down. I will calm down. Sorry about that. Okay, so let's continue. I really wanted to calm down because of the feedback I was getting from YouTube. Right, so let's continue. In question number 41, it says 1 over 3 log p base 10 is equal to 1. Please, when solving a question like this, you deal with this first. Now, recall this. This is the idea that will help you there. So it means that this will be what? Log p to the power of 1 over 3 to base 10 will be equal to 1. So this P raised to the power 1/3 to be still equal to 1. Now at this point, remember we said that log x to a base equal to y will mean what? A, the base to the power equal to the number. The base to the power equal to the number. So that's what I'm going to apply here to mean that P, or let's write in the way you can understand, 10 raised to the power of 1 will be equal to P raised to the power of 1/3. At this point, I can rewrite because the standard practice is that I must keep the unknown on the left-hand side. So that will be P raised to the power of 1/3 will be equal to 10. 10 raised to the power of 1 means 10. 10 raised to the power of 1 means 10. Now, P raised to the power of 1/3. We use our concept of antonyms here. English language becomes very important here. The antonym of a cube is cube root. And the antonym of a cube root is what? A cube. Now, how do we apply that idea here? If I'm going to move this across equality, it will change its identity. A king becoming what? A slave, or a slave becoming a king. So for a cube root, it will become what? A cube. So P will now be equal to 10 raised to the power of what? 3. And what is 10 raised to the power of 3? It means 10 multiplied what? 3 times. And as such, P will be equal to 1,000. It will be what? P 10 having, or 1 having what? 3 zeros in front of it. So that will be P equal to 1,000. And with that, we have solved this problem. So we'll go to another year now and see what that has to offer us. So many questions here, and I just realized that what I'm going to do is I'm going to take a lot of these questions separately and clear out. But let's see with the time allowed us, let's see if we can go over, at least get through one more question paper before we go. Right, so I'll clean this off. I'll give you some time to process that. Now, the question I'm considering comes from SSC November 2004. SSC November 2004. And let's see if I have that right. It is question number 6B. And it is a theory question. SSC November 2004, question number 6B, and it is a theory question. Okay, so let's see how we can handle that. It says that if log 3 base 10 is 0.4771 and log 5 base 10 is what? 0.6990. It says evaluate without using tables or calculator. That is work based with these terms given to you. A, Roman figure 1, log 7.5. Roman figure 2, remember this is base 10. Roman figure 2 log 15 or 1,500 base 10. So these are the two questions we are going to try to handle. log 7.5 base 10. Those are 2 questions we're going to try to handle. Okay. All right. So this is what we are having. This is what we're having. How do we solve this? Now, look at 7.5. Maybe I should clean this part so that I can use that to explain some of the ideas, or maybe I'll solve. Okay, let's solve on this part, and I'll use this part to do some explaining. Now, look at Roman figure 1, log 7.5 base 10. Remember that 7.5 can be 75 divided by 10. Your idea or approach conform with, look at it, so log 3 base 10 and log 5 base 10. You have no discussion in terms of 2 or whatever. So you need to understand that whatever you're doing must fall within this. All right. So I know that 7.5 will be what? 75 divided by 10. So I will come here and say that this is something as what? Log 75 over 10 base 10. So what do I do next? I can now say that this is something as what? Log 75 base 10 minus log 10 base 10. How? We had said earlier that if you divide numbers, what are you doing to their logs? You are subtracting. Anytime you divide numbers, you are subtracting their logs. So we already know what this answer will be, because we know that log 10 to base 10 will be what? 1. The log of a number to its base is what? 1. So I can now worry about splitting this one. Now, let's see if I can split 75. I can split 75 to what? 25 times 3. Remember that my splitting is based on the knowledge of 5 and 3, that are closest value I need to use. And this is what? Minus 1. How did I get minus 1? Log 10 to base 10. Now, having done that, when I multiply numbers, what am I doing to their logs? I'm actually adding them. So this will be log 25 base 10 plus log 3 base 10 minus 1. Now, this one will not be an issue for me again because I already have a definite value for it. I say that. So my challenge now will be this one. Now look at this. 25, the prime factor of 25 is 5. How many times will I multiply 5 to get 25? That will be 2 times. So I'll have what? Log, what? 5 raised to the power of 2 to be 10 plus, what is this value? 0.4771 minus 1. I cannot write this because I said earlier that log of a to the power is as n log a. So I'll apply that concept here. This will become what? 2 log 5 base 10 plus 0.4771 minus 1. What is log 5? 0.6990. So this will be what? 2 times 0.6990 plus 0.4771 minus 1. So I can multiply this one out. What will this give me? This will give me 1.3980. How I got that right? Let's see. 0893. All right. I won't assume that I've done the right thing. Plus 0.4771 minus 1. So I can add these two together. So I can just look for somewhere in my book and add that. So that'll be 1.3980 plus 0.4771. Remember, you are told not to use calculator. 1, 5, 7, 8, That's 1.8751. I want to trust that my answer is right. So that will be 1.8751 minus 1 minus this one. So my final answer becomes 0.8751. That will be the final answer to that question. Catch our breath a little and then we'll solve the second one. Try to be as slow as possible here so that we'll get the process. What I do when I solve problem is that I try to show you what I'm thinking in my mind. There are different options to solving this problem, but I've used one, just one of them. It's like the multiverse. All right, so let's take on the next one, which will be our final for the night. Okay, so we'll try to pick on this one, Roman figure 2, and that is log 1,500 base 10. The same approach. Now, look at this. This will be the same thing as saying log to base 10, 15 times 100. Remember, this is the same thing as 15 times 100 because I can actually break 15 into two other things. So I can continue from here. Now, this is more like another approach solving this one now. Now, the approach I use will be a function of what I am saying. And I always tell my students this, you are the one in the examination hall. So we give you ideas, but what you use in the examination hall is a function of what you can remember. So this is what I know that 1,500 is same as 15 times 100. I can also break this to become what? 15 is what? 3 times 5 times what? This 100 can be written as what? 10 raised to the power of 2. So with this, remember that we said that if you multiply numbers, you are adding their log. So I will just say log 3 base 10 plus log 5 base 10 plus log 10 raised to the power of 2 base 10. All right. So this will now be equal to what? Log 3 base 10 plus log 5 base 10 plus 2 log 10 base 10. I hope you know why that is. The log of a number to a given power, let's say x, is the same thing as saying what? N log A. So that's the idea we're applying here. So what is log 3? 0.4771 plus what is log 5? That will be what? 0.6990. What is log 10 base 10? That's 1. Is that not? 1 times 2 will give me what? 2. So I can add these two together. If I add these two together, I'm going to get something like, so maybe I'll add them here, 0.4771, 0.6990, and that will be 1, 6, 7. If I've done the right thing, 1.1. So that will be 1.1761 plus 2. That will give me 2.1761. So that will be the final answer. Well, let's check. Because in questions like that, you may be told to approximate to the nearest decimal place or whatever. But fortunately for us in this question, we are not told to do any of such. All right, so we're done with that question. And I think we have we've done a good job today. So let me just give us a minute or two to note what we've done so far, and maybe I'll give maybe a minute or two for questions or on areas that were not very clear. Okay, so maybe we'll take a comment or two, because this is where I want to call it a day, because a number of us might already be feeling tired. But I trust you enjoyed the class. So maybe we'll take a question or two from us. Thank you for all of us who have, those of us who have stayed on to the end of the class. I really appreciate your effort. It's not easy. It's not very easy. It's not very easy, but I really want to appreciate your effort. You will see it counts. The other day we had visits from the NECO, and my former maths teacher, I was told my former maths teacher who was working with NECO had retired 5 years ago, the man who brought me to what I'm doing today. So everything I do on this maths platform is because somebody sowed a big seed into my life, and I am compelled to keep on this work. So thank you very much for staying to this time. We will meet again tomorrow, and I'm going to post questions, and like what I'm trying to do now, I'm trying to drop my number on the chat, so that for those who are watching from out, we're going to send assignments on that. Okay, so I just tried to drop on the YouTube channel. For those of us who are on Zoom, likely you already have my contact. So I've dropped that on the chat. So after now, I'm going to snap and send loads of questions you can use to practice. And then when you're done with them, you can always private chat me and we'll look at them together. But tomorrow I'll be taking on a different topic. Tomorrow. Thank you very much. Mamu return. Have a blessed night. Thank you.